In this video, we're going to work on the 7.5 to 7.7 review. So I wrote SOHCAHTOA on my sheet already because I want you to remember you're going to always be thinking SOHCAHTOA when solving right angle trig. Okay, so number one thing, let's look at what we have. They have given us all three sides, so let's look. So you have this side, you have this side, you have this side. Here's your hypotenuse. It's always, always, forever and ever, directly across from the right angle. So I know that this is my hypotenuse, and I'm going to call it that. Now they want us to find angle X and angle Z. So I want you to think inverse trig whenever they say they want an angle. And that's going to be either sine to the -1, cosine -1, or tan -1. So that has to be your thought process. Okay, so let's try to find angle X first. So from angle X's view, I can see that this will be the opposite, and that this over here will be the adjacent. The adjacent is touching, but is not the hypotenuse. Okay, set up your ratio. You're going to say, since I'm going to do opposite over adjacent is going to be tan. So I'm going to say the tan of X equals opposite over adjacent. You have to have this ratio first. Then when you want to get X by itself, think about moving that tan over to the right, and when it goes over to the right, it becomes tan to the -1. That's going to get you back your angle. So we're going to see that X is going to be 54.5 degrees. Okay, so I want you to practice using inverse trig for both of these angles. So I'm going to have you go ahead and you can do another trig problem to get the other angle. So let me just change my color, and over here I want to get Z now. So from Z's perspective, I'm going to do opposite over adjacent again, but this time from Z's perspective, that's not the adjacent. That is now the opposite. This is not the opposite, but from angle Z's point of view, that is the adjacent. Okay, so let's set it up. So I need to say, I'm going to do the tan because I did opposite over adjacent again. So the tan of angle Z equals its opposite, which is 5, over its adjacent, which is 7. So to get Z itself, I'm going to have to use my inverse trig, and the function I'm doing is tan. So that means angle Z itself ends up being 35.5 degrees. So remember, you want to have your degree symbol whenever you are solving for an angle. Okay, here's one, here's the other. And what you should notice is that if you were to add X plus Z, you will get 90 degrees because those two angles are supplementary. Okay, so let me just put this in a little box. So this is the second one. Put this in a little box. Okay, so we've got those two done. And now we can also check our answer down here. Okay, we just got 54.5. That checks. And we got 35.5. That checks. Okay, let's do the next one. Number 2, they've also given you all of your sides. You've got 17, which is the hypotenuse, because it's across from the right angle. You have 8, which is one of the legs. And depending on which angle you're coming from, it's either going to be opposite or adjacent. Same is true for 15. Okay, so I'm going to put SOHCAHTOA here again. Okay, and I'm going to say, let's try to find angle X. And from X's position, the 15 is the opposite. And the 8 is the adjacent. Okay, so opposite and adjacent. That's going to give us tan again, and we'll switch it up next time. So I'm going to say the tan of angle X equals opposite over adjacent. Okay, get X by itself by taking the inverse tan of 15 over 8, and you shall find that your X is going to be 61.9. Okay, so that X right here is 61.9, and that checks. Okay, so I'm going to box this off. Okay, so when I box it off, I'm going to now move on to my next angle, which is going to be tan, Z. And let's do something other than tan. So why don't I say this, from this angle's perspective, let's do cosine. This is now not the opposite from Z, but it's the adjacent. So that means this is not the adjacent. And then this is the hypotenuse. So if I'm going to do adjacent over hypotenuse, then this time I'm not going to do tan. I'm going to do adjacent over hypotenuse. I'm going to do cosine. So the cosine of angle Z equals adjacent, which is 15 over 17. So angle Z therefore equals the cosine of -1 of 15 over 17. And I'm going to just do this in my calculator. I'm going to hit second cosine, and I have 15 divided by 17, and I have so I have 28.1 is my angle. Z is 28.1. That checks. And let's put it in its own little box so you can see what I've done. Okay, so we have both of the angles, and if we were to add the angles together, so X plus Z would get us 90 degrees because they have to be supplementary. Okay, that brings us to question number 3. Here it says solve the right triangle for all. So all missing sides and all missing angles. So what's missing? Well, angle A is missing, X is missing, and Y is missing. So let's set that up. So let's get the angle first because that's the easiest. I'm just going to do subtraction at this point. So 90 minus 38, and that's going to give us what? It should be about 52. So that equals 52 degrees. So that's my angle right here. It would be 52 degrees. So then let's see if we can get some of the missing sides. So I'm going to write SOHCAHTOA right here, so we have it right in front of us. And I'm going to say from angle 38's perspective, this is the opposite, and this is the hypotenuse. Opposite over hypotenuse is going to be sine. So the sine of 38 equals X over 50. That's a one-step problem. 50 times the sine of 38. So you should be getting, let's see, and I'm looking for X. So that's going to equal X. And what will X equal? So it looks like X is going to equal 30.8. Okay, so I get 30.8 for X, and I'm looking down here, and that checks. I also had 52 for the top angle. That checks. So let's see what else we can get. We're still missing side Y. So let me box this off. Okay, now let's go ahead and we'll get side Y. So I'm going to say, if I want to do Y, why don't I do cosine? So from 38th point of view in green this time, this will be the adjacent, and this will still be the hypotenuse. So I'm going to say that adjacent of a hypotenuse is going to be cosine. So the cosine of 38 equals y over 50. So then 50 times the cosine of 38 will equal y. Put that in your calculator and you should be getting y is 39.4 in length. So this y is 39.4. That matches down here. So I know I have the correct answer, most likely. And I'm going to box this guy off. And we have another problem done. Okay? So again, you should be trying to do this on your own and then checking with the video as needed. Okay, here's another one. Now let's highlight in yellow what I need to find. I need this angle. Ooh, I need this angle too. And I need this side. Okay, so that means that I can't do subtraction to get any of my angles initially. So why don't we try to do the following. Let's get angle B. And if I want to get the angle, I'm going to have to use two values that were already given to me. So from angle B's perspective, 17 is the adjacent and 40 is the hypotenuse. So I'm going to say adjacent of a hypotenuse. Here you can put SOHCAHTOA again. So when we do finally take our quiz, I'm expecting to see SOHCAHTOA written a lot of times on your paper and also on your review. So when I look at that, I see adjacent of a hypotenuse, and adjacent of a hypotenuse is going to be cosine. Okay, keep it going. So let's use cosine. So I'm going to say the cosine of angle B is adjacent over hypotenuse. Therefore, B equals, remember, use the inverse of 17 over 40. And angle B will be 64.8 degrees. So this is 64.8 degrees. So that's the first thing we need to see is it checked? And it does. Okay, next thing. Now that we have one angle, let's just use subtraction to get the other. So 90 minus 64.8 will give me 25.2 degrees. That checks. So I'm going to box this guy off. That was for the cosine to solve for a missing angle. And now let's try and get another problem solved. I want to figure out what x is. So I'm going to use the 64.8, and I'm going to say from that angle's perspective, this is the opposite, and this is still the hypotenuse. So I'm going to say an opposite over hypotenuse means that I'm not going to use cosine this time, but instead I'm going to use sine. So the sine of 64.8 equals x over hypotenuse. So one-step problem, 40 times the sine of 64.8 will equal x, and I'm getting x equals 36.1. Now, this says 36.2, but that's okay, and I'll show you why. Let me just box this guy a little bit. Another way I could have gotten that missing side was to do the following. I could have said x squared plus 17 squared equals 40 squared, because that's Pythagorean theorem. So then I would have said x squared equals 40 squared minus 17 squared. I don't want x squared, I want x. So take the square root of both sides. Excuse me. Okay, you put that in your calculator, then you will get 36.2. So sometimes it's a slight rounding issue, but don't let that worry you. 36.2, 36.1, are equivalent answers for our purposes. Okay, so that brings us to this next little section. And this next little section wants us to find the angles, and they gave us the sine, the tan, and the cosine of an angle. They gave it to us as a decimal instead of a fraction. Don't let that trouble you. When you want to do your angle, we always do the inverse trig. So this is what goes in your calculator, and you should be getting 12.8 degrees, and that works out well. Okay, B, your calculator should go tan to the -1 of the number they gave you, and that should get you exactly 70 degrees. And then you can either just put this down, but that would be not a good thing to do. Oops, so sorry. Look what I did. I want to do cosine and put the number in and verify that you are getting 37.9 degrees. Bingo, done. Okay, so we have all of this done so far. If at any point you need to go back and go over this, go ahead, because this is good, solid work, and you need to have a very solid understanding. Okay, now I have these four triangles. So what I'm saying is I want you to solve each of these four triangles. So why don't I pick a different color for each triangle? This first one's going to be green. Know that SOHCAHTOA is always something that you're going to be using. So let's see what we can solve. We're missing this angle. So let's highlight to see what we're missing. So we are missing this angle, we're missing this side, and we're missing the hypotenuse. Okay, so if you want to solve for the angle first, the easiest way to do it, since they gave us the other angle, is to just do simple subtraction. So 90 minus 52 will do it for us. And that's going to give us an angle of 38 degrees. So that angle goes right there. Okay, so down here on the angle D line, I'm going to put 38 degrees. Okay, next one. Let's go ahead and we'll try to find side D. I'm going to use this angle, and I need to solve for one thing. So why don't I say this is opposite and this is adjacent. So therefore, I'm going to be using opposite over adjacent. You should be saying tan. Okay, so let's set it up. You need your ratio. Tan of 52 equals opposite, which is 80, over D. Okay, this is a two-step problem. First step, cross multiply. D times the tan of 52 equals 80. Divide by tan 52, divide by tan 52. D is going to equal, if you do 80 divided by tan 52, you should get 62.5. Okay, so that's my D, 62.5. I'm going to put it right down here, and that's all set. Okay, next one. We still need to get F, so we did this, so that's all done. Now to get the hypotenuse, I can't use tan because that doesn't include a hypotenuse. So why don't we use, since I like the 80, because it's not rounded, I'm going to use the 80, which is going to be the opposite from 52, and I'll use the F, which is the hypotenuse, and I'll be able to solve for the hypotenuse. So I'm going to say, since I did opposite over hypotenuse, I'm not using tan. Oops, sorry. I'm instead going to use what? You should be saying it out loud already. You should be using sine, right? So I can say the sine of 52 equals 80 over the hypotenuse. Cross products tell us f of sine 52 equals 80. Divide by sine 52. Divide by sine 52. F will equal 101.5. So this is 101.5, and we can add 101.5 down here. And we are done the first triangle. Okay, so the next one is the KL triangle. So let me just move this guy a little bit out of the way. Okay, so now let's see if we can get this second triangle solved. So let me think for a second. We're going to change our color. We still need the SOHCAHTOA, so I'm going to write this now in the color I'm using. We are missing the following items. So we need 2 angles and 1 side. Okay, so we have to do trig to get one of the angles, and then we can do subtraction to get the other angle. Okay, so let's see what we have. So from L's perspective, I have the opposite and I have the hypotenuse. So since I have both of those, I can use that to solve for the angle I don't have. So we're going to use our sine right here, and we're going to set it up. So we'll say the sine of L equals opposite 7.7 over hypotenuse, which is 13. L therefore equals sine to the negative 1 of 7.7 over 13. So 7.7 over 13 is going to give us an L angle of 36.3 degrees. So this is 36.3. That means that, so down here for L, I'll put 36.3 degrees. Then to calculate K, I'm going to say 90 minus 36.3, and I'm going to get 53.7. 53.7 goes right there. Okay, so now we have to get the X. So I'm going to take an angle, doesn't matter which one. I think I'm going to do the 36.3. And I'm going to say opposite and adjacent. Opposite and adjacent is going to be tan, right? That's going to be tan for what I'm going to do right now. So let's say the tan of 36.3 equals opposite over adjacent. Do your cross products. So x times the tan of 36.3 is going to equal 7.7. Okay, so I'm going to try to squish this over here. And so I want to get x by itself. So I'm going to say x equals, let me back up for a sec, 7.7 divided by the tan of 36.3. Because I had to divide both sides by tan 36.3 to get rid of it and to get x by itself. So if I put that in my calculator, I'll get an x value that's going to be equal to 10.5, and that second triangle is all done. Okay, let's go up to this top one. We're going to change our color again. And for this top one, the quickest way to get angle C is to say 90 minus 57, and that's going to give me 33 degrees. So angle C is 33 degrees. Okay, so then next thing, I'm going to look at what's missing, and let's highlight it so that we're focused on it. A is missing and C is missing. So that's the opposite and the adjacent are both missing. So let's use angle 33 and say opposite over hypotenuse. Opposite hypotenuse. Opposite over hypotenuse is going to be sine. So the sine of 33 equals opposite, which is the unknown, over 70. That's going to be a one-step problem. 70 times the sine of 33 will equal C, and little side c is going to be 38.1. So this is 38.1. So come down here, and for C, put 38.1. Okay, so we're going to do the other side now. Let's do the adjacent over hypotenuse. And I'm going to say that the cosine of 33 degrees equals A over the hypotenuse, which is 70. Also a one-step problem. So 70 times the cosine of 33 will equal, will equal 58.7. Down here, 58.7. Okay, one more triangle. Okay, so this last one here, let's see what we're doing. We're finding two angles. So I need to find this angle and this angle. And I see I have missing hypotenuse. So let's try to get an angle. So why don't we do this? Let's go with angle I. So if I go with angle I, let's see what color I'm going to do. I think I'll do the light blue. Okay, we'll go with angle I. And I'm going to say, okay, this is opposite and this is adjacent. We have them both. So we can say opposite of adjacent is tan. The tan of I equals 77.2 over 81. I, therefore, is tan to the negative 1 of 77.2 over 81, and we get I equals 43.6. So that can go down here. Okay, 43.6. To get H, all you're going to do, since I know this is 43.6, take 90 minus 43.6, and you're going to get 46.4. This angle is 46.4. We've got one more thing to do, and that's get the missing hypotenuse. We're going to have to use either sine or cosine to get the hypotenuse. So why don't we do, I don't know, let's do sine. So I can say the sine of 43.6 equals opposite, which is 77.2 over the y. Okay, that's a two-step problem. Y times the sine of 43.6 equals 77.2. Y equals 77.2 over sine of 43.6. That goes in my calculator, and I'm going to get a y value of 111.9. So that can go right on this line, 111.9, and we have completed this page. Okay, so that was a really good exercise, getting lots of different values. Okay, so let's move on to these problems. So first off, it says, write each equation in standard form and then indicate whether the quadratic is upward facing or downward facing. So that's in A. And then in B, identify the y-intercept. So first step, let's write it in the proper form. So y equals, the x squared comes first, 3x squared minus x minus 7. That's the proper form. Okay, the second one's already in the proper form, so we're okay there. So the first thing I want to know is whether it's upward facing or downward facing. So remember, if the leading coefficient is positive, then the quadratic looks like this. So that's upward facing. Okay, so that's one thing. Remember that to get the y-intercept, you could set all the x's equal to 0, or you can just grab the constant. Either way, your y-intercept will be negative 7. Looking at the next one, I'm seeing that the leading coefficient right here is negative. That means I will have a downward-facing parabola. And to get my y-intercept, I just grab off the constant. That's where it crosses the y-axis. Done. Okay, so then for the next ones, we have 4 more of these quadratics, and we're going to figure out the x and the y values. We have to get both the x and the y values. So let's talk about these. Let's first look and see whether they're all in the right form. So leading coefficient, or the x squared, is first. That all looks good. Okay, everything's already in the right form. So then I'm going to figure out what x is. So x equals negative b over 2a. Therefore, x is going to be negative negative 6, and negative negative 6 is positive 6, over 2a. If a is 1, 2a is 2. So x is going to be 3. So far I know the x value of the vertex is going to be 3. Now let's figure out the y value. Plug in, so why don't I get rid of this so it doesn't confuse things. Okay, plug in for your x, the 3. So I need 3 squared minus 6 times 3 plus 8. 9 minus 18 plus 8. 9 minus 18 is negative 9, plus 8 is a negative 1. So y equals negative 1, and now we have the coordinate pair of the vertex. Okay, let's go on to the next one. Okay, so we need to figure out what x is. X is negative b over 2a. So if negative b is negative 4, negative negative b is positive 4. Okay? Okay, 2a. If a is negative 1, 2a is negative 2. So this should equal negative 2. So now we have my x. So let me erase these things, and we want to find the y. So y equals negative parentheses, negative 2 squared, minus 4 parentheses, negative 2, plus 2. Okay, negative 2 squared is positive 4. So I have a negative from the front and then a positive 4. Negative 4 times negative 2 gives me a positive 8 and then plus 2 more. So what is that going to give us? Negative 4 and an 8 is a positive 4, plus 2 is a 6. So that's going to be 6. So now I have negative 2, comma 6 for the x and y of my vertex. Okay, 2 more. All right, let's look at this. We want to figure out what the vertex is. So I'm going to say x is negative b over 2a. So here is your negative b is negative 1. So negative negative 1 is positive 1. And 2a, if a is 2, 2 times 2 is 4, x is 1/4. Okay, let's get rid of those as we try to figure out what the y is. Keep it as a 1/4. Don't change it into a decimal. Okay, 2 times 1/4 squared minus 1/4 minus 1. Okay, 1/4 squared is 1/4 times 1/4, which is 1/16. Okay, minus 1/4 minus 1. Okay, so what does that give us? So we have 2/16. So 2/16 are here. 2/16 can also be 1/8, but let's leave it as 2/16. Okay, turn the fourths into 16ths by multiplying by 4/4. So that's minus 4/16. Turn the 1 into 16ths by multiplying by 16/16. Okay, so now what do we have? 2 minus 4 is a minus 2. Minus 2 minus 16 is a minus 18/16. That's also a minus 9/8 if we divide them by 2. Okay, so what's our vertex? Let me make this a little bit smaller. So we make a little bit smaller. Oops, I didn't want to do that, certainly. Well, so I'm going to write down, since you saw the work already, let me just write down what I have. 1/4, comma, negative 9/8. Okay, so my x was 1/4, and my y ended up being negative 9/8. So just rewind if you need to see how that happened. Okay, last one. So here we go. We want to find the vertex, and the x value is going to equal negative b/2a. Here's my negative b. It's negative 9. Negative 9 is positive 9. A is the 3. 2 times 3 is 6. Let's divide that by 3. So that's going to be 3 goes into 9 3 times. 3 goes into 6 2 times. So let's use 3/2. 3/2 is the x part of the vertex. Okay, let me erase that. And let's go ahead and start plugging in so we can get the y. So 3 times, okay, 3/2 squared minus 9 times 3/2 plus 2. Okay, what do we have? 3/2 squared is 9/4 times the 3 minus 9 times 3 is 27/2 plus 2. Okay, it looks to me like I want things over 4. Let me just continue down here. So 3 times 9 is 27/4. Let's multiply the 27/2 by 2/2, and we get minus 54/4. Let's multiply the 2 by 4/4, and we get plus 8/4. So 27 minus 54 is negative 27. Negative 27. Was that true? Negative 27. Yeah, let me just look at this for 1 second. Hang on 1 sec. Okay, so 27 minus 54 plus 8 gives me a negative 19, and they're over fourths, and I'm happy with that. Okay, so we've done the entire review packet. So there's going to be more reviews before we have our test, but you may want to go back and do this again. If you only listen to me do it, or only write down what I write down, and never think it through yourself, then this will not be an effective way to prepare yourself for the assessment. Okay, you've got to do it yourself and then check your work. Okay, well, thank you for listening, and I hope you feel more confident about your SOHCAHTOA and your inverse trig.